This video is on translating between words and inequalities. It's lesson 45 in your book on pages 284 through 287. Now we've done a very similar lesson to this, which was translating between words and expressions or equations. The difference here is that we are talking inequalities. So we still have all those words that tell us that we need to add, such as sum or and or total. And those numbers that tell us we need to subtract, like difference. Also multiply, like product or of, and divide, stuff like quotient or divided by. The difference is, instead of using is as equals, there's going to be different words that tell us that something does not equal. So an inequality is a mathematical statement that compares quantities that are not equal. That's why it's inequality, not equal. The inequality symbols and their meanings are shown in this little chart right here. So this one where the open end is to the right is the less than symbol. Open end to the left is greater than. It implies that the first number is bigger than the second. The one with the open end to the left and then the line underneath it is less than or equal to. The opening to the left with the line underneath it is greater than or equal to. And then there's the equal sign with a line through it, which we've been using for undefined values, and that's does not equal. So we're going to translate these sentences into inequalities, and these are examples that need to be in your notebook. The quotient of a number and 2 is less than or equal to 6. So we still know that we have an operation. In this case, the word quotient tells us that our operation is going to be division. So we have the quotient of a number, and we know that a number means some variable, we'll call it x, and 2. And then we have is less than or equal to. So since it says less than or equal to, we have to use our less than or equal to symbol, and then we're going to have to say 6. So the quotient, so dividing a number and 2, is less than or equal to 6, would translate into x divided by 2 is less than or equal to 6. Again, very similar to when we're translating them into equations, however, we're using inequality symbols instead. In this next one, it says 1/2. That's something we're definitely going to have to use. Is greater than. That tells us that we're going to use the greater than symbol, which is that. Then we've got product, which tells us that we're going to multiply. A number, which we use a variable for. I'm going to use y in this case. And 3/4. So to turn this into an algebraic sentence, I'm going to write 1/2. Then my greater than symbol, because it's 1/2 is greater than. Whoops, sorry, this is not a greater than, that's less than. There we go. Is greater than the product of a number and 3/4. So a number I'm going to call y, and then since I'm doing product, I'm going to multiply it by 3/4. Now I could also write that as 1/2 is greater than 3/4 y, and it would still mean the same thing. Alright, now here's another one that needs to be in your notebook. It says the difference of a number and 2.8 does not equal 8.2. Now this word right here, difference, tells us that we're going to have to use subtraction. And this right here that says does not equal tells us we need to use the inequality symbol does not equal. So the difference of a number, which we're going to call m, and 2.8 does not equal 8.2. So to translate that into an algebraic expression, we'd have the number, and then since we're subtracting, we'd have minus 2.8, and then we would say it does not equal 8.2. So there's our inequality. Now this next one says the sum of the product of 20 and a number and 75 is at least 195. Now notice that, let's see, we've got sum, so that tells us we need to do addition. We've got the product of 20 and a number, which tells us we need to multiply 20 times a number, so 20x. And 75, so we're going to add that 20x plus 75. And then it says is at least. Now, we don't have an inequality symbol for at least, right? There's no inequality symbol that's called an at least symbol. But if the least it is 195, then that means it must be greater than 195, or it could be equal to, because it has to be 195 or bigger. So to translate this into an algebraic expression, we'd say 20x plus 75 is greater than or equal to 195. So whenever you see at least, that means you're going to use greater than or equal to. Now we can also translate inequalities into words, just like we can do the other way around with expressions. So this inequality, and this is an example that needs to be in your notebook, this inequality is 6 is greater than x plus 8. Now, we could write it just as it is, so 6 is greater than, because our symbol is the greater than symbol. And then we could say the sum of a number and 8. Now, we could also say 6 is at least the sum of a number and 8. Because a greater than symbol, well, we couldn't say at least because it couldn't be equal to. So we could say 6 is greater than a number plus 8, or a number added to 8. So there's several different ways that we could write that. Now here we've got 2.5z is less than 15. So notice we're doing multiplication here. So we could say the product of 2.5 and we could say and z, or we could say and a number. And then since we have the less than symbol here, we could say is less than 15. And again, there are several different ways to write this expression in words, but this is one possible way. Alright, here's some more examples that need to go in your notebook. So in this case, we have negative 2x plus 4 is is greater than or equal to negative 8, and we need to write it in words. So notice that here we have multiplication happening, and then there's some addition, and then our inequality symbol is greater than or equal to. That means that we could say greater than or equal to, or we could say is at least. So we can use either one of those expressions. So here I might say the sum of the product of negative 2 and a number or negative 2 and x and 4. So we've got the product of negative 2 and x, and then we've got the sum of that and 4, so that shows we're adding 4. Is, and we could say is greater than or equal to, or we could say is at least negative 8. So that's one way that we could write that. Now in the second one, it says 3x minus 6 is less than or equal to negative 30. So if we're going to write this, that we wanted to find the product of 3 and x and then subtract 6, we could possibly write the difference between, because difference tells us to subtract, and then maybe we could say negative 3 times a number and 6. So the difference between negative 3 times a number and 6, so that shows we're subtracting negative 3 times a number and 6. And then here our symbol is less than or equal to, so we could either say it is less than or equal to, or we could say it is at most. Because if it's at most, that means that the biggest that it can be is that next number, so negative 30, which means that it has to be less than or equal to that. So we could say the difference between negative 3 times a number and 6 is at most negative 30. So when you see those words at most, that means you've got less than or equal to. And here's our last example that needs to be in your notebook. It says Jonas is purchasing 15 screen-printed warm-up suits for his soccer team. He can spend $1,000 at most. There is a setup fee of $25 for screen printing. What can he spend at most on each suit, including tax and printing costs? Okay, so we need to figure out what can he spend at the very most on each suit. So I'm going to call what he can spend at most on each suit X. So that's the cost per suit. Okay, so I know that he can spend at the most $1,000, right? But there's going to be a setup fee of $25 for the screen printing. So let's see, if we have $1,000 that he can spend at most, $1,000 for everything, and there's that $25 fee, we have to subtract that $25 to figure out what he can spend per suit. So that gives us $975 that he's going to be able to spend on each suit total. Now, we know that he wants to create 15 warm-up suits. So if he's got $975 to spend, and he wants to buy 15 suits, we're going to divide that by how many suits he wants, 975 divided by 15, to figure out X, his cost per suit. And when we do that, 975 divided by 15, we get $65. So that means X is $65. Now, we don't want to have equals here because he doesn't have to spend $65 on each suit. He can spend at most $65. So that means those words at most means we want to use the expression less than or equal to. So X, the cost per suit, must be less than or equal to $65.